Okay. Assalamualaikum. Today we are going to present our final project for database BITP 1323. And my name is Sharif bin Saleh.
My name is Muhammad Shafiq bin Khalili.
My name is Muhammad Irfan bin Razali.
My name is Muhammad Amin Rahman bin Aslam.
My name is Muhammad Hakim bin Jafri.
Okay, first we are divided into 4 chapters, which first chapter is introduction, chapter 2 is database design, chapter 3 database implementation, and chapter 4 in conclusion. So for introduction, the database we are going to implement is restaurant management system, where the restaurant have become more than just place for amusement. They are a need for families and individuals, a fundamental and crucial requirement for all restaurant management system is inventory management. Inventory serves as a record to ensure all working uniformity. Creating a database for the restaurant is a fundamental and significant project in our life, since it will save customers' time and effort when dealing with reservation issue, restaurant service, and also organize the operation of the restaurant. And for problem statement, Shafiq.
Okay, so now for the problem statement, the restaurant management has been faced with difficulties such as inventory mismanagement and stock wastage due to inefficiency in the system. It will lead to crucial revenue loss and delay service time from place. Thus, leave a bad impression to customer and lowering the restaurant fames and review. Therefore, we as a group has an approach that need to be taken, such as designing a systematic inventory management, which is a database for the restaurant system. Okay, next.
So for our objective, first is to identify the entities, attributes, the relationship of restaurant management. And second, to achieve a data management system of restaurant management. And third is to manage a rational model between the entity in restaurant management system.
For the scope, first module to be developed is restaurant management, stock system, and customer service. And second, target user is families and couples.
For significance, first, organized operations. Restaurant management software system manage inventory, specially manage, aid in scheduling, and assist in many other important tasks. Second, boost customer loyalty. Some systems have the capability to use value features such as coupons as well as extensive gifting options. Third, automatic payments. Fast, reliable, and safe payment processing is something you cannot have without good restaurant management software.
Okay, for chapter 2, database design. We created an entity relation diagram which we have 6 tables. First table we have staff, second table we have customer, and the third table is order, fourth table is food, fifth table is payment, and we have one bridge table which is food and order. Every table we created a primary key and the entity. Okay, next for business rule.
Okay. So for the business rule, we have one staff member can manage one or many orders, or one or many orders can be managed by one staff member, which means that only one staff can manage one or many orders, but one or many orders can only be managed by one staff. And next, we have that each customer can make one or many orders. Like credit table, we as a customer, if we go to the restaurant, we can only make one orders, right? Per time. We can't make 2 or 3 orders per time. So that's why each customer can make one or many orders. No, I mean one or many, which means they can also make one or many orders. They can also make many orders can be made by one customer. And for the next one, we have one order can only make one payment, and one payment can be made by only one order. We can pay only for one order. And for the fourth one, we have many foods can be taken in one or many orders. One or many orders can take one or many foods. Next.
So for the data dictionary, we have 5 big data table, which is staff, customer, orders, food, and payment. So for the first one is staff. For the staff table, our primary key is staff ID. And then we got the other attribute, which is first name, and other is the last name, and the fourth is the telephone number for the staff, and the fifth is the position. So for the second table, our primary key is customer ID. So the other attributes is email of the customer, and then we got first name of the first customer name, and then the last name for the customer, and also telephone number and address. So for the third table, which is orders, our primary key is the order ID. So the other attribute is the order date, and the third attribute is food ID, which also work as the foreign key for the food table. And the fourth is the customer ID, which is also work as the foreign key for the customer table. And the last one for the orders is staff ID, which work as the foreign key for the staff table. For the fourth table, which is food, the primary keys of this table which is food ID. The other attributes which is food name, quantity, price, and item category. So for the last table in this final project, which is payment, which is the first primary key is payment ID. The other attribute is payment type, amount, and order ID, which the order ID work as the foreign key for the order table.
So for chapter 3, database implementation. We have data definition language, DDL. For the first, we can create table staff. Second, we can create table customer. And third, as well for create table food. For the next is to create table order. And the last is to create table payment.
Okay, for DML insert statement, we have insert a new rule into the staff table for all columns. For example, we have insert into staff value, staff ID, first name, last name, telephone number, and position, which the first name is Jason Momoa, telephone number, and the position is check. And for the next query, we inserted a customer table, inserted a data for customer table, which the customer ID is C056, first name Asman, last name Jalil, telephone numbers, and address, email. After that, we created a next query. We insert a new row into the food table for all columns. We insert a data for the food table, which food ID, food name, quantity, the price, and the item category, which nation food. And for the next query, we inserted a new order. We have order ID, order date, and we retrieve the food ID, customer ID, and staff ID from the food table, customer table, and staff table. And for the last query, we inserted a new row into the payment for all columns. We have payment ID, payment type, amount, and order ID. And for the delete statement, we have tried to delete all row in staff table, which we can use SQL statement delete from staff, where they can delete all the data from the staff table. And the next is customer table, we delete from customer. We can delete a customer data table. The next, we have delete row in food table that has the food ID of F012, where we delete from food where food ID is F012, which means the food ID F012 data will be deleted. And the next query is delete rows in orders table that have order date 13 June 2023. For the SQL statement, delete from orders where order date is 13 June 23, where they will be delete the data where which the order date is 13 June. And for the last query, delete rows in the payment type is e-wallet. Delete from payment with payment type is e-wallet, where they will be deleted the e-wallet data from the payment. Okay, for update, we have changed staff first name the ID S001 to Johnny, where we can update the name from Jason to Johnny. And the next query, change customer address that customer name Sharif to number 32 Durian Tunggal Melaka, which means the query is to update the address where the customer first name is Sharif. And the next is change food price of quick courier to 3 ringgit. We can update the price of food from the quick courier. We can set the food price is 3 ringgit. And the next query, we update order date from orders to 20 March 2023 of order ID, where we update the order date 20 March 2023, where the order ID is 0054. And the next is change payment type to e-wallet for payment ID P001, where we update payment and set payment type to e-wallet where the payment ID is P001. Okay, next for SQL data manipulation, language, relational algebra, and select statement.
For DMS selection and projection statement, query 1, the question is list all staff that work as chef. The SQL statement, select from staff where position is chef. Second query, the question list name, telephone number for the customers who live in Melaka. For the SQL statement, select F name, L name, Telno address from customer table where address like Melaka. For query 3, the question lists the price for all the Malaysian food. The SQL statement is select food name, price item, price, and item category from table food where item category is Malaysian food. Query 4, list all orders that have been made in June. The SQL statement, select from orders where order date like June. Query 5, SQL statement.
Sorry. Okay, continue. Sama. Sama.
For query 5, list how many customer take paid via cash. The SQL statement, select count, payment type as total from payment table where payment type is cash.
Okay, now for the aggregation and grouping statement. So for the query 1, what is the total quantity of food item in each item category? For this question, we want to find the total, which means we are using sum for the SQL statement. So select item category, sum quantity as total quantity from food group by item category, and we will get output such as Western food, diesel food, which is the total quantity of this kind of food and drinks. For the question 2, how many orders were made by each customer? So how many? We will using count. Select customer ID, count as order count from orders, group by customer ID, and then we get output customer ID, how many order count for each customer ID. So next question. For question 3, what is the average price of food item in each item category? So for the average, we use AVG for the SQL. Select item category, AVG price as average price for food group by item category. So as output, we'll get item category. We'll get average price for each item category. Question 4, how many staff members are there in each position? How many? As last question, we use count. Select position, count as staff count from staff group by position. We'll get staff count for each position. And now for the last question, what is the total amount of each payment type? So for each payment type, we'll use sum. So we want to find the amount, the total amount. So SQL statement, select payment type, sum amount as total amount from payment, group by payment type, and we'll get output as total amount for each payment type. That's all.
Alright, so for the inner and outer join operation, so for the first query, which is retrieve the staff information along with the corresponding order details order. So this query is about the inner join. So the SQL statement is select staff eccentric, order eccentric from staff, inner join orders on staff, staff ID equal orders to staff ID. And get the information regarding the staff. So for the second query, which is retrieve the customer details for all customers who make a payment using an e-wallet. So for this query is also using the inner join. So we use select customer eccentric from customer, inner join orders on customer ID equal to customer order customer ID. Inner join payment on payment the order ID equal to orders order ID where payment type equal to e-wallet. So for the third query, which is retrieve the food item along with the corresponding staff information for all order. So for the third query is also using the inner join. So the SQL statement is select food eccentric, staff eccentric from food, inner join orders on food, food ID equals orders food ID, inner join staff on orders dot staff ID equals staff dot staff ID, which will get the food item along with corresponding item. So for the fourth query, which is retrieve the customer details and corresponding payment information for all cash payment. So this one is using the left outer join, which is the left join outer. So the SQL statement is select customer eccentric, payment eccentric from customer left join payment on customer ID equal payment.order ID and payment type equal to cash. So for the last one, for the inner outer join, retrieve, the first query is retrieve the staff information, customer details, and food item for all order placed by customer from Naker. So this one is using the inner join as well. So the SQL statement is select staff eccentric, customer eccentric, food eccentric from staff, inner join orders on staff, staff ID equal orders staff ID. Inner join customer on orders, customer ID equal to customer ID. Inner join food on food, orders food ID equal to food ID, where customer address like Malacca. So we get the information regarding the staff and the food and the order of the staff. That's all.
So for the nested operation, first question is to find customer's name that order nasi lemak ladu here. So for the SQL statement, select first name and last name from customer, where customer ID, select customer ID from orders where food ID equal to select food ID from food where food name nasi lemak ladu here. So we can get the output for the like this by the game. So for the question 2, display the detail of order that is handled by staff name Ipan KM. So for the SQL statement, select all from customer where customer ID, select customer ID from orders where staff ID equal to select staff ID from staff where first name Ipan. So we will get the output customer ID C073 for Nora Kakak. So the question number 3, display the payment issued by Nora Kakak. For the SQL statement, select all from payment where order ID in select order ID from order where customer ID in select customer ID from customers where first name Nora. So we will get the output for the payment ID is P005. The payment type is card. For the question 4, display the customer that used the wallet. So for the SQL statement, select all from customer where customer ID in select customer ID from orders where order ID in select order ID from payment where payment type is e-wallet. For the output, we will get 3 output here, C046, C091 and C056. For the last question, first find customer details that order on 1 June 2023. For the SQL statement, select all from customer where customer ID in select customer ID from orders where order date equal to 1 June 2023. For the output, we will get customer ID C030 for Sharif Hansen.
For the conclusion, system contribution, the entire operation and efficiency of a restaurant are significantly improved by the restaurant management system database in a number of ways. Its major contributions include the following. Okay. The database efficiently organized and saves several kinds of restaurant-related data, including customer information, menu items, inventory, personal information, and sales records. This company improves data accessibility and enables fast information retrieval and analysis. The database makes it possible to generate and analyze reports on a variety of performance parameters, such as sales trends, well-liked menu items, client preference, and financial insight. This report offers insightful information that may be used to make decisions, plan marketing campaign, and pinpoint areas for development by enabling effective other processing from development and individualized service. The system contributes to an improved overall customer experience. It makes it possible to accurately track client preference, run loyalty programs, and handle feedback, all of which improve customer happiness and retention. system drawbacks. The restaurant management system database may have several shortcomings that need to be addressed despite its benefits. First, complexity. For staff employees who are not tech savvy, the system may have a high learning curve. The system and mistakes during system use might be caused by convoluted user interface or difficult operation. Scalability. As the restaurant develops or expands, the system may encounter scalability issues depending on the design and execution if the database is not built to handle a high volume of data or several concurrent users. Performance problems may occur. Limitations on integration. The system may have trouble merging with other applications or systems that are already in use. Data exchange, cooperation, and general operational efficiency can all be hampered by the restaurant's lack of integration capabilities. Suggestions for improvement. The following ideas for development might be taken into account while enhancing the restaurant management system database. User-friendly interface. To make the system simple to use for staff members, it should have an intuitive and user-friendly interface. Visual signals, streamlined procedure, and clear navigation can assist shorten learning curves and mistake rates. Scalable architecture. To manage growing data, quantity, and user traffic, the database should be designed with scalability in mind. System efficiency and responsiveness may be increased by using effective indexing techniques, streamlining queries, and taking distributed data-based systems into account. Enhancing the system integration capabilities can help data flow between the restaurant management system and apps seamlessly. APIs, application programming interface, or standardized data formats can make it simple to integrate with tools like software or e-commerce site. Advanced analytics. Increasing the system analytical capacity can give users deeper insight into consumer behavior, market trends, and operational efficiency. Advanced analytics methods such as machine learning algorithms may be used to find hidden patterns and support data-driven decision making.
Okay, that's all for the presentation today. Okay, thank you
Thank you.
and bye.
Thank you.
Thank you all. Bye.
Thank you for watching.
Sorry.